Imagine you're adrift in the vast, silent ocean of space. Suddenly, a flash. A signal, brighter than a billion suns, blazes across the cosmos and vanishes in less time than it takes to blink. What was it? Where did it come from? This isn't science fiction. It's one of the most electrifying mysteries in modern astronomy. Fast radio bursts, or FRBs. These are not your everyday cosmic whispers. An FRB unleashes more energy in a single millisecond than our sun does in 3 entire days. Think about that. A colossal burst of power, a cosmic shout, traveling for billions of years across the universe, only to be caught by our telescopes for a fleeting moment, and then silence. The story begins in 2007. Astronomer Duncan Lorimer and his student David Narkovic were digging through old data from the Parkes Observatory in Australia. They were looking for pulsars, but they found something else, something impossible. A signal so powerful, so brief, it defied all known explanations. For years, many astronomers were skeptical. Was it just a glitch? A microwave oven opened at the wrong time in the observatory's kitchen? Believe it or not, that actually happened and created false signals called perytons, but the Lorimer burst was different. It showed signs of having traveled through intergalactic space, a long and arduous journey that stretched its signal in a very specific way. This was the real deal. Since that first discovery, we've detected hundreds of these enigmatic flashes. They seem to be coming from all directions in the sky, from galaxies far, far away. This tells us they aren't just a local phenomenon in our own Milky Way, they are happening all over the universe. It's like hearing knocks on a wall, but the wall is the entire cosmos. So, what in the universe could possibly create such an immense burst of energy? This is where the real fun begins, because right now, we just don't know for sure. But we have some fascinating suspects. One of the leading culprits is a type of celestial object called a magnetar. Picture a neutron star, the superdense remnant of a massive star that went supernova. A neutron star is already extreme, a city-sized object with more mass than our sun. A magnetar is a neutron star on steroids. It possesses a magnetic field 1,000 trillion times stronger than Earth's. It's so powerful it could wipe a credit card from halfway to the moon. The theory goes that sometimes these insane magnetic fields can get tangled and snap, creating a starquake on the magnetar surface. This event could unleash a tidal wave of energy that we see as a fast radio burst, and we have some good evidence for this. In 2020, for the first time ever, astronomers detected an FRB coming from inside our own Milky Way galaxy, and guess what they found at the source? A known magnetar. Moment for astronomy. This FRB wasn't as powerful as the ones from other galaxies, but it was the first time we could definitively link a burst to a specific type of object. It was the cosmic smoking gun we had been searching for. But hold on. The mystery isn't solved just yet. While the magnetar theory is strong, it might not be the whole story. Why? Because some FRBs are repeaters. They don't just flash once and go silent, they flash again and again, sometimes sporadically, sometimes in a pattern. One of the most famous repeaters, FRB 1102, has been observed bursting hundreds of times. This repeating behavior challenges the simple starquake idea. A single, catastrophic event like a starquake might explain a one-off burst, but how does it happen over and over? This has led to other theories. Perhaps the magnetar is young and active, constantly flaring up. Or maybe it's not just a magnetar on its own. What if it's part of a binary system, orbiting another star, or even a black hole? The gravitational dance between these two massive objects could be triggering the bursts periodically. Imagine the magnetar swinging past its companion, and each time it does, material is ripped off or its magnetic field is disturbed, letting out a radio scream. And then there's the really wild stuff. Could FRBs be the collision of two neutron stars? This is an event, so cataclysmic it literally shakes the fabric of space-time, creating gravitational waves. While this could certainly generate the energy needed, it's a one-time event. A collision can't explain the repeaters. So maybe there are different types of FRBs, created by different cosmic engines. Some from magnetars, some from collisions, and some from something else entirely. The most tantalizing and, let's be honest, exciting possibility is one that scientists are very cautious about. Could these be signals from an advanced extraterrestrial civilization? Are we eavesdropping on the energy source of a star-faring society? Perhaps these powerful beams are used to propel their light sails through interstellar space. It's an extraordinary claim, and as the saying goes, it requires extraordinary evidence. So far, the signals seem to be broadband, like natural static, not narrowband and information-rich like we'd expect from a deliberate communication. But we can't rule it out completely. The universe is a very big, very strange place. What makes FRBs even more valuable is what they do on their journey to us. As a radio wave travels through the billions of light-years between its home galaxy and ours, it passes through the stuff that fills the void, the incredibly thin, almost non-existent gas of the intergalactic medium. This material, which astronomers call the cosmic web, is very hard to see, but FRBs act like cosmic lighthouses. By studying how the signal is stretched and dispersed by this gas, we can measure how much material it passed through. For the first time, we are able to map out this invisible cosmic skeleton and weigh the universe. FRBs are not just a mystery, they are a tool, a unique probe to understand the large-scale structure of everything. So, where do we go from here? The hunt is on. Telescopes around the world, like CHIME in Canada and FAST in China, are scanning the skies, detecting new FRBs almost daily. They are building a massive catalog of these events, hoping to find patterns. Are they clustered in certain types of galaxies? Do repeaters and one-off bursts have different properties? Every new detection is a new clue. We are living in a golden age of discovery. Just a decade ago, these signals were a fringe anomaly. Now, they are one of the hottest topics in astrophysics. We are cosmic detectives on the trail of a profound mystery. Are we witnessing the birth cries of magnetars, the death screams of colliding stars, or something far stranger? We don't know yet, but every flash brings us closer to an answer. The universe is speaking, and we are finally learning to listen. Thank you so much for joining me on this journey into the unknown. If you're as fascinated by these cosmic mysteries as I am, make sure to hit that subscribe button and ring the notification bell so you won't miss our next deep dive into the wonders of space. Let me know in the comments what you think is causing these fast radio bursts. Until next time, stay curious.